Okay, let's take a look at this question now. So we are given this right-angled triangle ABC. We're given the hypotenuse 4 root 3m. We're also given the angle here, angle CAB, to be pi by 3 radians, and we're given a midpoint m. So how do we, what the question is asking us to find is the integer m. Oh, right. And we're also given one more piece of information that angle ACM is sine inverse of square root m over 78. So what we can do is sine inverse bring over straight away. Then we get sine of angle ACM to be square root m over 78. Now this is, you might be thinking, oh, sine of an angle, then maybe I can use TOA CAH SOH, right? The SOH in particular. So, but you look at the diagram and you realize, oh, cannot. Why? Angle ACM is actually part of this triangle here, which is not 90-degree triangle, a right-angled triangle. So you cannot just use TOA CAH SOH. Instead, you need to use the next best alternative, which involves a sine, which is sine rule. So I noticed that I can actually use this pair and this pair for my sine rule. So this, the length as well as the angle, and the length. So the goal now is to find out the lengths as well as the angles. So I can fill in I can use sine rule and I can get this ratio here, sine of angle ACM, which is this pink angle, divided by its opposite length, which is this guy, AM, equals to sine of angle AMC, yes, correct, sine of angle AMC divided by its opposite length, 4 root 3m. Now, notice that there are a few unknowns here. AM is unknown, angle AMC is also unknown. Now, angle ACM, we also cannot find it out, but we can leave it alone because we can later on substitute with we can substitute the sine of angle ACM directly with square root m over 78. But what is AM? What is AM? So that's what we are going to find out first. I noticed that AM is actually equal to MB because M is a midpoint. Or in other words, AM is also equal to half of AB. And I can find out the length of AB by doing this procedure here. What I realize is that this is a right-angled triangle. I have an angle pi by 3 radians. I also know its hypotenuse. So I can already find out its adjacent length. How? By doing this. I'll take the cosine of this pi by 3 radians, which is adjacent over hypotenuse. So adjacent being AB, hypotenuse being 4 root 3m. Try to solve for AB. What do? First, you evaluate what's cosine pi by 3, it's 1/2. Then 4 root 3m times over. You get 1/2 times 4 root 3 as your AB. Half and 2 cancel off. Half and 4 cancel off to give you a 2. So it's 2 root 3m. 2 root 3m is your length AB. But you have to divide by 2 now, times half, to get a root 3m as the length AM. So now that I know the length AM, I can substitute in over here, root 3m. Oh. Okay. Now my goal is to find out what is angle AMC. And I already found out beforehand that it's 106.102 degrees and it's an approximation. Let's try to find out what's this angle AMC now. Looking back at the diagram, where is angle AMC? It's this orange angle over here. How do I find this orange angle? I can just take 180 degrees minus away this blue angle. But I don't know the blue angle. So now my goal changes to finding out what is this blue angle. What I realized is that this blue angle is a part of this right-angled triangle here. So I can use TOA CAH SOH to go and find out this angle. But before that, I need to know the lengths of this right-angled triangle. So far, I only know root 3m as my MB. I have yet to find out that this is 6m. I have yet to find out that this is 6m. So my goal now is to find the length BC, which we already found out just now is 6m. So let's figure out how we can do that. I noticed that actually this BC is not just belonging to this small right-angled triangle. BC also belongs to this big right-angled triangle. And in a right-angled triangle, to find the lengths, we can use Pythagoras theorem. We can use Pythagoras theorem. We already know the hypotenuse is 4 root 3m. We already know this entire length AB is 2 root 3m. So by Pythagoras theorem, we can work it out to find 6m. And here is the working, okay? The two lengths are 4 root 3m and 2 root 3m. So the unknown length is BC. To find BC, you just take the square root of 4 root 3m bracket square minus away 2 root 3m bracket square. Simplifying, I get 48m square minus 12m square, which is 36m square. Square root both, okay, then now I can split it up into each of its factors. So square root 36 times square root m square, you'll just get a 6m as your length BC. Good. So go back to our diagram over here. We got a 6M as our BC. We got adjacent length BM. We want to find out this unknown blue angle. What ratio can we use? Tangent. That's the only possibility, opposite over adjacent. So we can find out this angle by tangent. That's one possibility, right? That's one possibility to find out this angle. Tangent of that angle to give us opposite over adjacent, 6M over root 3M. And that's exactly what I did over here. Find angle at CMB, take the tangent, you get 6M over root 3M. What happens? The M cancels off, you're left with 6 over root 3. Can you find out the proper procedure to find angles, right, is to first find the basic angle. Then after that, you consider which quadrant it should be. Tangent is a positive value here, positive 6 over positive root 3. So you expect it to be in quadrant 1 or quadrant 3, which are these two angles. But you reject this guy because we are actually just trying to find an angle CMB, which is an angle inside a triangle that cannot be more than an obtuse angle. Cannot exceed 180 degrees. So therefore, this is by elimination, we know that this is our only possible answer for 73.897 degrees. Notice that this is a rounded off value, right? It's not the exact angle. So angle CMB is this guy. So now we know angle CMB, we can then find out angle AMC. Just take 180 degrees minus that angle CMB because they were angles on the same straight line. Subtracting, and I get this angle, 106.102 degrees. Again, it is no longer an exact value, it's an approximation of the actual angle. Now, knowing that this is 106.102 degrees, angle AMC, I can substitute it back in over here with 106.102 degrees. Then I try to solve for M. So what can I do? Let's just leave the sine angle ACM alone first to keep things simple. I'll try to get rid of the fraction. So root 3M, I can multiply by both sides by root 3M. What happens is that they will just cancel off. Some of the factors will just cancel off. Then you're left with this guy over here. Sine of angle ACM equals sine of 106.102 degrees over 4. Then now I know that sine of angle ACM was from 1 root m over 78. So maybe over here I should write down substitute in 1. Then you get root m over 78 equals sine of whatever over 4. Solving for m, how? Just multiply the 78 over, you get 78 over 4, which is 39 over 2 times sine of that angle there. Then, since you have a square root, how to get rid of square root? Square both sides of the equation. So m equals to this guy squared, which gives me, if you type in the calculator using 1.102, the non-exact angle, you'll get 351.0004023. So it's very, very close to 351, but it's not exact. It's not precise. The question was asking for an integer value of m. It has to be an integer, right? It has to be an integer. So there's a problem with this method. It's not precise. The actual answer is 351. Okay, the actual answer is 351, but we are not allowed to just round off and conclude it's 351. Instead, right, we need to identify where this decimal came from. Okay. The actual answer should have given us an exact value of 351, but we managed to get an answer that involves this decimals, which is inaccurate. And where did this inaccuracy come from? It's actually from this approximation over here. We use an approximated value of this angle, which gave us the problem of a non-exact value of m. So now I'm going to show you a different approach, a more accurate approach that avoids this estimation step. Over here, what we are actually, the sine of 106.102 actually came from this guy over here, sine of angle AMC. So now our question is, how can we find an exact value to the sine of angle AMC with, how to find an exact value to the sine of angle AMC. And one such approach is to avoid finding out the value of angle AMC and instead finding out the sine instead as an exact ratio. What do I mean by that? So let's just look back at the diagram. Here is angle AMC, it's an obtuse angle. So if we know, we should already know the sine of an obtuse angle is really just equal to what? It's equal to sine of its acute angle. And what's the sign in front? SIGN sign. It's still positive, right? It's still positive. Sorry, got cut off. Let me try again. Positive in front. There should be a positive in front of the sign because it's a quadrant 1 angle. Acute is a quadrant 1 angle. So what does that mean in terms of this diagram? It means that in order to find the sine of this orange angle ACM, it's actually exactly equal to the sine of this blue angle CMB. Okay, and now what is the sine of this angle CMB? You realize that it's a right angled triangle. So all you need is opposite over hypotenuse. Opposite here, hypotenuse there. We already found out our opposite length 6m. Can we find out our hypotenuse and exact precise length? Yes, we can, because we already know this MB is root 3m. We know this BC is 6m. We can use Pythagoras theorem again to find out the hypotenuse length. So let's find out our length CM. So, sorry, please ignore this. Let's take a look at length CM, how to find out the length CM. Over here, we can find out the length CM by taking square root of what? This square and that square, which is root 3m and 6m. Root 3m and 6m, and square each of them and take the sum. Okay, like this, just Pythagoras theorem. Then simplifying, we get root 3 square is just a 3m square, plus 6m square is 6 square m square, 36m square. Combining them, we get square root 39m square, which is actually just square root 39 square root m square, simplifies to a m. That's our exact length. CM is square root 39m. Okay, so from knowing the length of CM, can we find out what is the sine of angle AMC now? Yes, it is exactly equal to the sine of the acute angle CMB, which in turn is equal to opposite over hypotenuse, which is 6m divided by, sorry, I forgot to label. What was the length again? Square root 39m. So let me just label on my diagram, square root 39m. So square root 39m. And you notice the m cancels off. So it's 6 over square root 39. That's our exact length. Exact ratio of sine of angle AMC. Okay, over here, sine of angle AMC is exactly 6 over square root 39. So over here, instead of substituting in with the angle sine with 106.102 degrees, we could have done this instead, which is what I'm about to show right now. We can just get rid of this ratio and replace it with the exact value 6 over square root 39. So let me just repeat that for all the other ratios, for all the other signs. It's just 6 over square root 39 all over. So over here, you multiply by a 78, you still have a 6 over square root 39. And another 6 over square root 39. Yeah, so over here, before we take the square, right, what we realize is that 39 over square root 39, what is it equal to? 39 is actually square root 39 times square root 39. So if you have a divide by square root 39, one of them will cancel off. So this means that we can actually get square root 39 at the top multiplied by 6 over 2. Okay? This 39 and that 39 cancels off a little bit. One of the fact you can cancel off a square root 39 from this 39. You're left with a square root 39 at the top. Bracket, square. What else can we cancel before we take the square? 6 over 2. 6 over 2 is just a 3. So what we get at the end of the day is actually 3 square root 39 whole thing squared. This one is 3 squared times square root 39 squared. What happens when you square a square root? What happens when you square a square root? They cancel each other off to give you a 39. 3 squared is a 9. 9 times 39. 9 times 39 is just 351. So there is our exact value. Okay, Ken. One more thing to take note of is that over here, when we found out our length BC using Pythagoras theorem, there was actually a different way to do it, which is over here, you got a length BC. We also know this angle, we also know this hypotenuse. So actually, we could have took the sine of this pi by 3. Let me show you how to do it. Maybe I'll just write it down over here. The sine of this pi by 3 is opposite over hypotenuse, which is our BC over hypotenuse 4 root 3m. So you can actually evaluate sine pi by 3, right? It's sine of 60 degrees, which is root 3 over 2, an exact value, equals to BC over 4 root 3m. Then you can just make BC the subject. So BC is equal to root 3 over 2 multiplied by 4 root 3m. Notice that the root 3 multiplied by a root 3 will give you a 3. So 4 times 3 is 12 over 2m, which is 6m. So that was another way to get the same length 6m. Yeah, then that's all for this question. The answer for integer m is nothing but 351. Okay.